A wooden pallet may look like one of the simplest products in a warehouse, but it has to carry heavy loads, survive repeated forklift handling, and remain stable through thousands of miles of transportation. This factory produces industrial shipping pallets from raw logs, taking the wood through sawing, sizing, assembly, nailing, marking, and final treatment before the pallets are ready to move goods through warehouses and supply chains. The process begins in the log yard, where large tree trunks are sorted and prepared for the sawmill. Workers use chainsaws to remove damaged ends, protruding branches, and irregular sections before the logs enter the main production line. This early trimming is important because uneven wood can interfere with automated feeding and reduce the amount of usable lumber recovered from each log. Even for a relatively low-cost product like a pallet, getting the most material from every tree has a major effect on production efficiency. A forklift now lifts several prepared logs and places them onto the sawmill infeed system. Heavy rollers and mechanical guides take over from here, positioning each trunk for cutting. The logs vary naturally in diameter and shape, so the machinery must hold them securely while maintaining a straight cutting path. Accurate positioning helps the mill recover long, usable sections, instead of turning valuable wood into unnecessary sawdust. Before continuous sawing begins, workers prepare the large bandsaw system. The long steel blade runs around massive wheels and has to be joined, sharpened, tensioned, and adjusted correctly. Workers inspect the teeth, grind the cutting edge, and check the blade position by hand. A blade this large moves at high speed, so poor tension or damaged teeth can produce rough lumber, wandering cuts, or even damage the machine. This is a good example of a process where experienced maintenance work directly affects both safety and product quality. The first logs now travel through the saw. A vertical bandsaw blade slices through the timber, while powered rollers control the feed rate and keep the log moving steadily. The first cuts remove the rounded outside sections and gradually convert the irregular trunk into a more manageable rectangular form. Operators watch the process from nearby controls and adjust the log position when necessary. The goal is to recover the widest possible boards while avoiding major defects such as deep cracks, knots, or damaged sections. The partially squared timber passes through additional sawing operations. Each cut produces long boards with increasingly consistent thickness, while bark and unusable outside material are separated from the main lumber stream. The machinery performs most of the heavy work, but blade condition and feed speed still matter. If the log moves too quickly, the cut may become rough or uneven. Too slowly, and production efficiency drops while energy use increases. Finished boards are transferred away from the saw and stacked into large bundles. Forklifts move these stacks around the yard and production area, keeping different dimensions organized for the next stage. The lumber does not need the furniture-grade appearance of decorative wood. but pallet boards still have to remain reasonably straight and consistent. Warped or badly split pieces can weaken a pallet or make automated handling difficult later. The long boards now enter secondary cutting equipment. Workers feed the lumber through machines that rip and cross-cut it into the narrower pieces required for pallet construction. Different parts of a pallet perform different jobs. Deck boards create the load-carrying surface, while thicker stringers or support pieces transfer that weight toward the forklift openings below. Keeping these components close to the specified width and length allows the finished pallets to stack uniformly and fit standard material handling equipment. Shorter wood pieces are also produced from the remaining lumber. Instead of discarding every offcut, usable sections can be converted into support blocks and other pallet components. This helps the factory extract more value from each log. Bins and racks keep the different pieces separated, while forklifts move them toward the assembly area. Even small dimensional differences matter here, because several blocks must support the pallet at the same height if it is going to sit flat under a heavy load. Before assembly begins, workers prepare pneumatic nail guns and large quantities of collated nails. These tools use compressed air to drive fasteners rapidly into the wood. Compared with hammering each nail by hand, pneumatic equipment provides much greater speed and more consistent penetration, but the operator still determines exactly where every nail goes. A fastener placed too close to the edge can split the board, while one driven in the wrong position may fail to secure the joint properly. The pallet begins to take shape on a simple assembly table. Workers first position the heavier support members and place deck boards across them at controlled spacing. The boards are aligned by hand before being fixed in place with pneumatic nailers. Consistent spacing does more than make the pallet look orderly. It distributes the load across the structure while keeping the overall weight and material usage under control. The workers move quickly, but every board still has to be seated flat before the nails are driven. Assembly continues as workers check the outer edges, replace unsuitable pieces, and complete the remaining nail patterns. The finished pallet is handled from several sides before leaving the station, giving the workers a chance to catch cracked boards, protruding nails, or uneven components. Despite the simple construction, dimensional consistency is essential. Warehouses often stack pallets several levels high, and automated forklifts depend on predictable openings and overall size. Completed pallets are now moved away from the assembly tables and stacked in large groups. Forklifts handle the finished units instead of workers lifting them manually, allowing the factory to move dozens at a time. The tall, uniform stacks also provide a quick visual check. If one pallet is significantly warped or incorrectly assembled, it becomes much easier to notice when it does not sit properly with the others. The lower deck is added and fastened into place. Workers continually reposition the pallet so they can reach each joint without sacrificing speed or accuracy. The nails have to penetrate deeply enough to secure the boards, but should not be driven so aggressively that the wood splits. That balance between machine power and operator control is one reason pneumatic tools work so well in pallet production. Identification markings are now applied directly to the wood using a stencil. These marks can identify the manufacturer, production specification, or other information needed for tracking the pallet through storage and distribution. Applying a permanent mark also makes different pallet batches easier to separate. Workers keep the stencil in a consistent position so the information remains readable even when hundreds of pallets are stacked together. Stacks of pallets are positioned inside a large treatment system and lowered toward a liquid bath. Depending on the pallet specification, this type of treatment can help protect the wood against mold and other deterioration during storage. Uniform exposure is important because untreated areas can behave differently when the pallet encounters humid conditions. After treatment, forklifts move the finished pallets into the outdoor storage yard. They are stacked into tall, orderly columns, ready to be shipped to factories, warehouses, and distribution centers. What began as rough logs has passed through trimming, industrial sawing, blade maintenance, sizing, component cutting, pneumatic assembly, inspection, marking, and treatment. A wooden pallet may spend most of its life hidden beneath cargo, but modern logistics could hardly function without it. Every shipment it carries depends on something surprisingly basic: properly cut wood, strong joints, accurate dimensions, and skilled workers building them the same way, time after time. Packing tape may look like one of the simplest products in a warehouse, but producing thousands of identical rolls requires careful control of film tension, cutting width, winding pressure, and packaging. This factory converts giant rolls of adhesive-coated BOPP film into the smaller packing tape rolls used every day to seal cartons for shipping and storage. The process begins with an enormous master roll, weighing far more than a worker could handle manually. A forklift carries the roll to the slitting machine, where it is mounted onto a heavy steel shaft. Workers remove the protective wrapping and carefully prepare the leading edge of the film. The material is typically biaxially oriented polypropylene, or BOPP, coated with a pressure-sensitive adhesive. BOPP is widely used because it is thin, strong, transparent, and resistant to stretching during normal packaging work. While the jumbo roll is being prepared, another machine cuts long paper tubes into individual cores. These cardboard cores form the center of every finished tape roll. A rotating blade divides the tube into equal width sections, and each cut must match the width of the tape being produced. The adhesive film is now threaded through a series of guide rollers and tension control cylinders. As the master roll unwinds, these rollers keep the film flat and prevent wrinkles while maintaining a steady pulling force. The wide sheet moves rapidly through the machine before reaching the slitting section. Tension control is one of the most important parts of the process. Too much tension can stretch the polypropylene film, while too little can allow it to wander or wrinkle before it reaches the rewind shafts. Paper cores are positioned across the rewind shafts, and the wide web is divided into multiple narrow strips. Circular slitting knives cut the film continuously, while each strip is wound onto its own cardboard core. Instead of producing one roll at a time, the machine creates many rolls simultaneously. The shafts rotate at carefully controlled speed, so each finished roll develops the same diameter and winding density. If tape is wound too loosely, the layers can shift. Too tightly, and the core or film can deform. Once the required length is reached, the finished rolls are released from the rewinding machine and transferred into an automatic sorting system. A large rotating bowl guides the rolls into an orderly stream, turning randomly positioned products into a consistent orientation. The rolls then move one by one onto a conveyor. This type of automated feeding allows the packaging equipment to operate continuously without workers manually placing every roll, increasing production speed while keeping spacing predictable. The individual tape rolls now enter the protective wrapping stage. Thin plastic film is placed around each roll and sealed before the product continues through the line. This outer wrap keeps dust and contamination away from the adhesive edges during storage and transportation. At the same time, additional paper cores are being cut nearby, showing how several production stages operate together to keep the main slitting machine supplied without interruption. The video now gives a closer look at the high-speed slitting system. The adhesive-coated film moves over polished rollers while multiple narrow strips are created at the same time. Rotary knives are spaced precisely across the machine according to the required tape width. Their edges must remain sharp and accurately positioned. A worn or misaligned blade can leave rough edges, uneven widths, or small tears that later cause the tape to split while a customer is using it. What begins as one enormous adhesive-coated sheet becomes hundreds of compact rolls ready for warehouses, factories, stores, and homes. Packing tape may cost only a few dollars, but behind every roll is a fast, carefully controlled converting process where precision matters from the first cut to the final box. From wooden pallets to packing tape, these factories show how simple everyday products still depend on precision, speed, skilled workers, and reliable machinery. If you enjoy satisfying production processes and seeing how ordinary products are made, subscribe to KenTT Machine, leave a comment, and join us in the next factory journey.